All right, here we go. Complex operations. You know, your mathematical operations, adding, subtracting, multiplying, dividing, and you're going to throw in powers in there too because, you know what I times I is. Uh, but as I just said on the previous video, complex numbers, if you're looking at adding them or subtracting them, it's basically just combined like terms. So we're adding here. You know what? You can pretty much ignore the parentheses. 3 plus a negative 2 is 1. Negative 4 plus negative 4i plus 6i, that's 2i. Yeah, it's that easy. Now for subtracting, you got to think a little bit because that negative is being distributed. So, negative 4 and a negative 6 makes a negative 10. A 3i minus a negative, that's plus 7i is 10i. Guess what? Go to mode 2. Right there. You could type it in. And for adding and subtracting, there's literally, oh, the I is right here, this English button. Talked about that before, dude. No, not this class. So yeah, to get I on your calculator, you hit this button above 8, E and G. It's gray or brown or whatever heck color that is, but you don't need to hit the shift if you're in complex mode. If you're not in complex mode, it's not going to work. So just hit that E and G button. All right. And again, right there. That's the I. To do that, negative 10 plus 10i. There it is. So yes, the Casio FX115 ES Plus does complex operations for you. So if you got it, great. If you don't, well, you'll have to do some work by hand. Now, the bigger calculators, the TIs, those also do complex operations for you. But when you're dealing with fractions, with complex numbers, Casio's the way to go. Here we go. Let's just do it. 2 minus 2, that's nothing. Hey, that's nothing. I'm going to write it, sure. Negative 5 minus negative 2 is, excuse me, negative 7i. So yeah, that's, if you got nothing, it's nothing. Don't bother writing it. It's a negative 7i. So I added these two complex numbers together, and I got just an imaginary number, a pure imaginary number. So remember, it's either a real number, an imaginary number, or a complex number to put them together. Put a real number plus an imaginary number, that makes a complex number. That's how they're made. But if you're adding them together, you can get any kind of number. You can get a real, you can get an imaginary, or you can get a complex. Because real numbers are complex numbers, imaginary numbers are complex numbers. It's just that little 0 there. So that's going to give me a 3 plus 0i. So this one gave me a real number. But you see, we can still write it in the form of a complex number. So 3 is, in fact, a complex number. Think back to your Venn diagrams. If you have the number 3, not only is it an integer, but you can write it as a fraction, so it's rational. And it's, a real number. And then it is now also a complex number. Every single freaking number is a complex number, but not every number is anymore a real number, because now we got these little i's there. Those are imaginaries. Anyway, so if you were thinking about multiplying 3i times 2i, that would be 6i squared. So we need to know what I squared is. We need to know how to talk about the i's to a power. So to do that, best way I can think of is just to go through some and find out what the rule is, what the pattern is, whatever the heck you want to call it. You should be able to tell me the first one. What is meh to the 0 power? That's right, it's 1. Anything other than 0. 0 is an animal of its own. To the 0 power is 1. 1 to the 0 power, 1. A million to the 0 power, 1. I to the 0 power, 1. Anything to the first power is itself. So our answers are going to be in terms of I, okay? Or some nice real number if it is. What's I squared? You should know this. If I is the square root of -1, right? Let me just do this. If you watch the video explaining where I comes from, you already know the answer to this. So if I square both sides, I squared, the square root and the square just cancel each other out, is -1. Okay. Okay. Now, I'm going to do some trickery with some rules of exponents. I to the third power is the same thing as I squared times I, right? I to the first power if you wish. 2 plus 1 is 3, so yes, that's it. I know this is that's a weird symbol. This is -1. This is I. So this is just -I. So I to the third power is -I. That's just what it is. You see it? There it is. That's how magic works. I mean math. And my 4 was disappeared. There we go. I to the fourth, I'm going to write that as, guess what? I squared times I squared. Yeah, that's a nice one. -1 times -1. That is a +1. Huh. So I to the fourth power is 1. Okay. Oh, hey, now that's handy. I can write anything. I to the fifth is I to the fourth times I to the first, right? So that's just 1 times I. That's going to be I. And this is just going to be I to the fourth times I squared. So that's just going to be I squared, which is -1. And this, I to the fourth times I to the third, do you see the pattern yet? I hope you do, is -I. Ooh, what do you think this one is? It's I to the fourth times I to the fourth. What's that? What's that? Okay. I to the eighth is 1. So I can write this as I to the eighth times I to the first. And I start the pattern all over again. So here's the deal. We got a pattern. 1, I, -1, -I. 1, I, -1, -I. 1, I, -1, -I. That's the pattern. It's got 4 different possibilities. So in order to figure out in that pattern where we're at, all we have to do is look at our exponent, whatever it may be, divided by 4, and check out its remainder. Okay? So if I look at I to the 42, for example, if I divide 42 by 4, I get 10 with a remainder of 2. Remainder of 2. Look back at our pattern. What is the remainder here? 0. That's 1. The remainder here is 1. The remainder here is 2. So it should be -1. Let's see. If I divide 6 by 4, I get 1 with a remainder of 2. Our remainder of 2 has a -1. So I to the 42 is -1. So the rule, if you're looking at your remainders here, your remainder of 0 then it's 1. If you have a remainder of 1, then it's I. Your remainder of 2, it's -1. If you have a remainder of 3, it's -I. And you're dividing by 4, right? So that's your only possibilities. And if you don't believe me, let's just take our calculator over here. I'm in complex mode. Depends on which operating system your calculator has. Some of the newer Casios can do this. Some of the older ones, even though they're the exact same model, cannot. So if I do I to the 42nd power, mine gives me -1. Yours might not. Yours might give you an error or something. I don't know. But it's some weirdness with the calculator's operating system. They update them like every version. So if you have a version 2, I'm pretty sure they can do this. So this is the rule. Your remainder tells you, the remainder, if you divide your power by 4, tells you what your result will be. So keep this in mind. This needs to be ingrained into your brain. Let's look at I to the, let me do this. Let's ignore that W there. Okay, if you try and do this in the calculator, obviously that's too big of a number. It's not going to happen, especially if you're just trying to get the remainder. Sorry, my back's killing me. I'm old. Yeah. But we're dividing by what? 4. Does anybody remember their divisibility rules for 4? Of course you don't. Well, let's think about it. Maybe not. Anyway, the divisibility rule for 4 is if the last 2 are divisible by 4, then the whole thing is divisible by 4. Which means if you look at the remainder for just those last 2 pieces, then that will be your remainder for the entire thing. Okay, that's just the divisibility rules for 4. My wife was supposed to teach you those. I don't remember which year she did, and just decided she was going to skip them because she found them useless. I told her, no, don't skip them. They're not useless. I need them. But she decided to skip them because she didn't have time. With your class, she might have taught them. I don't know. Anyway, divisibility rule for 4 is look at the last 2 digits. Divisibility rule for 8, look at the last 3 digits. Okay, 8's not important. So if I'm looking at this, let's just do it in a calculator. I'm going to mode 1. So I'm pretty sure if I try and type this whole thing in, I'm not going to try it. It's going to give me some random E thing. So 69 divided by 4. I don't want that. I want the decimal. Now, you could, let's see. Yeah, you could do it as a mixed number and see that, oh, it's a remainder of 1 because it's 1/4. But if you just get the decimal, that, like if you're using your phone or something, you get 0.25. You should know that that's the remainder of 1. 0.25 is 1/4. So this thing is equal to I, because it's got a remainder of 1. That's it. Let's do another one. I'm going to do a small number. I'm not going to do that one. Let's do this one. So this one I can actually do in the calculator. So I'm going to show you that it does work. So if I take, again, I don't care about the 17. That's irrelevant. But what you could do if you still weren't sure what you, oops, I don't think that did anything. You could take this 17 and then multiply it by 4. Take away the 17, multiply it by 4, you get a remainder of 1. So extra though, 0.25 is 1 remainder of 1. You should be able to know that. It's 1/4. Anyway, 50 divided by 4 is a 0.5. That's a remainder of 2. Well, let's do the whole thing. 2, 3, 4. Still 0.5, remainder of 2. Again, we don't care about this number. We don't care. We just care about the remainder. It's got a remainder of 2, which means it is -1. That's it. That's powers of I, okay? Just, oh, I already did that. There's your power. There's your rule. Divided by 4. Divide by 4 and look at remainder. Negative though. Still works, but you have to realize that you're dealing with a negative remainder. We don't deal with negative remainders. We gotta, it's called modulus and all that crap, but whatever. You just add 4 to it. Okay. Let's say I to the 1, 2, 3. Well, if we do negative, that's not negative. Negative 1, 2, 3. Sure. I wonder. I'm not even sure if mine will do this one. Let's see. Okay, it's going to be I. Apparently. If I divide 123 by 4, I get 0.75, which is a remainder of 3. So it's a remainder of negative 3. Can't have negatives. Add 4 to it. So that's equivalent to a remainder of 1. Okay. I don't think I'm going to bother you with negative powers of I. They're not terribly needed. At least not right now. I can't think of anything. So I'll show you. It still works. Just got to add 4 to it because it's a negative remainder. Yeah. Anyway. If it's 0, obviously, if you have 4, that you don't need that 4 to be 0. But if it's a negative remainder, like negative 1, negative 2, or negative 3, add 4 to it to get what the actual thing is. Basically, just remainders of 1 and 3. Not going to worry about it. It still works. Just got to remember to fix it. Now we can multiply. So here we got the distributive property. That's all multiplication ever is with this stuff. 3i plus I squared. I squared is negative 1. Now I'm going to show you a shortcut so you don't have to waste so much paper. I squared goes to negative 1. That's all you got to do. Now we need to write it in the proper form, a plus bi, right? That's how we always write a complex number. Let's stick the negative 1 first. That's a positive 3i, so plus 3i. Distributive freaking property again. And I mean, if this was 2i, it's just like if it was an x. It's the same thing. So this is not new. Now this is an extremely important problem right here. Wow, that was terrible. Hey, yes, that's right. You recognize it as a difference of squares. Very good. Oh, wait, you didn't. Dang. So it's 3 times 3 is 9, minus 3i, plus 3i, minus I squared. Wow, what's going on here? Oh, wait, that's easy enough. I squared, that's negative 1. Those cancel out. 9 minus negative 1, that's 10. Huh. Whole thing just turns into a 10. That's exactly right. It turns into a 10. It turns into a real number. Whenever you change the sign in the middle, the a plus bi, whenever you change that sign in the middle of the real and the complex number, that is called the conjugate. Think about Spanish. It has absolutely nothing to do with it, but it's the same word. Conjugate, conjugate. There. Remember it. In order to divide, we need the conjugate, okay? So the next 2 seconds we'll need it. But I'm going to show you, yes, you can just take your calculator, make sure you're in complex mode, and you can type it in exactly as you see it, which is awesome for the ACT because you will most likely see something like this, and you need to do that and see that, hey, it is 10. I'm not going to show you see the work for that. So if you've got the calculator, use it. If you don't, do the work if you need to. If you don't need to do the work, you're good. Don't cheat though, there are multiple versions of the tests, as always. Let's do this one. Distributive property, right? 1 second, sorry. Just bear with me. Sorry, there, good. Now, 15 plus 35i minus 6i. Now, I probably need to see the work on, no, I don't need to see the work on this one personally, but I need to show the work or I would most likely make a mistake unless I'm typing in the calculator. Oops, squared. See, I made a mistake. And if you do make a simple mistake, I can give you partial credit if you write out your work. If you don't write out your work, no partial credit, obviously. So here we go. Why is that always negative? It's being -1. I need to pay better attention when I'm making problems so I can have different kinds. Anyway, 15 minus negative times negative positive, so that's plus 14 is 29. 35 minus 6 is 29. Wow. I really just made this up off the top of my head and it turned out to be interesting. Again, you can check it. Because I messed up somewhere. You can check it. And it is indeed 29 plus 29i. Wait. Okay, division with complex numbers. Most important thing is your complex numbers can't have I in the denominator. Just like whenever you're having a radical, you can't have a radical in the denominator. That's not simplified yet. As I said, we just need to multiply by the conjugate. I'm just looking because I thought I had more problems to practice, but I don't. Anyway, so we multiply by the conjugate of the denominator because we're trying to get the bottom part to not have i's. You're blinded. So if I were to take this and multiply it by 5 plus I, the conjugate, that would get rid of the i's in the denominator. Now, obviously, I can't just multiply by some random thing because that would change my entire value of my expression. So I need to multiply by 1 because that's the only thing I can multiply by that won't change it. So I'm going to write the same thing in the numerator because anything divided by itself is 1. So now I'm actually multiplying by 1. It just looks like a weird 1. It's 1, it just looks weird. So multiply your numerators, multiply your denominators, then simplify and all that good stuff. These usually take a bit of space, and yes, I will need to see the work on these. That's why I need to see with multiplication because you got to do it here anyway. So 3 plus 2i times 5 plus I. That's going to be 15 plus 3i plus 10i plus 2i squared. Again, I'm just going to leave that. I'm going to simplify it in a second. Conjugate, difference of squares. This part you can actually do in your head, or at least you don't have to show me the work. That's going to be 26. Excuse me. 5 times 5 is 25. The i's will cancel because I'm going to have 5i and a negative 5i. And I'm going to have negative I squared, right? Excuse me. So that's plus 1. So that's 25 plus 1 is 26. You can work it out if you need to. Then I'm going to combine my like numbers. You can just do that, but 9 times 5 is 25 plus 5i plus that's even weirder. Minus 5i minus I squared. And yes, these do become negative 1s just to make our life easier and not waste paper. We do that. 15 plus negative, so that's minus 2 is 13. 3i plus 10i, that's 13i. That's 13i. That's, I don't know if you can tell. That's 3 or not. So I'm going to do that. Over 25 cancels each other out. Minus and negatives plus 1 is 26. Not done. Cannot leave it like this. Must be in what form? A plus bi. Not all over something. You have to have two separate entities. Two terms, not one. This is one term. It's got a real and imaginary thing in one term. That is not done. Split it. Where did that come from? Who cares? 13 over 26, whatever sign it is, 13i over 26. Simplify the fractions. Still not done. Half. Okay, that's a half. Now you can write half I. That's fine. You could also write I over 2. That's fine. Or you could write 1i over 2. That's fine. I personally like half I. So that's how I'm going to write it. You cannot, however, write this. I doesn't go in the denominator, just like it doesn't go into the radical. It can go in the top, it can go in the middle, it can't go in the bottom. Put it in the middle. Me. All right, so whenever we're dividing with complex numbers, we have to multiply by the conjugate. So if I think about this as a 0 plus I, so I need to multiply by negative I. You could actually just use I, but I like you to always use the conjugate. That way you remember to use the conjugate. So we're going to do it. And it also makes, the last step easier. That's going to be negative 3i, negative I squared, which turns out to be negative times negative is positive. So it's negative 3i over 1, which is just negative 3i. Cool. Yes, for those of you thinking about your rules of exponents, that is I to the negative 1 power. So if we remember, I to the negative 1 power, that would be a remainder of plus 4 is 3, so that's negative I. So negative I times 3, yeah, that's exactly what we have here. You don't have to know that. But if you were thinking about it, good for you. If you weren't, then it's fine. This is how we're going to do it anyway. The end. Goodbye.